My name is Oleg Zhurakousky, and I just want to quickly explain why I'm the only person on stage. So you've probably seen there is Oleg Zhurakousky and Gary Russell, who is right there. And a week ago, you've probably seen different names for this talk. So what happened is that recently there was a change in leadership for this project, Spring Cloud Stream. Our dear friend and longtime Spring Sourcian and a longtime steward of Spring Cloud Stream, Marius Bogovici, who is somewhere over there, has moved on to new pastures. So I was asked about a month and a half ago if I would like to take the leadership role for this project. I've accepted, so the spotlight is on me right now. And but throughout this transition process, there was a bit of a miscommunication, and you know, when I found out that I have to deliver this talk, it was a little late to properly prepare to co-present with Gary or whoever, so we just decided that Gary's going to be here in case if I have any questions that I may not have an answer to, and he'll help me out, because he's been involved with the project for much longer. But other than that, we're good. So once again, I'm Oleg Zhurakousky. I've been with Spring Source. I'm in my second tenure with Spring. I keep saying Spring Source because that's where I started in 2008, just when they switched from Interface 21 to Spring Source. And then around 2012, I left the company. I tried to play with this new technology called Hadoop. That didn't turn out to be what I expected it to be, so I came back. And happy about it. So what we're going to talk about today is actually it's a very difficult topic because it's very sort of vague. I mean, under this abstract and under this title, there's a lot of things we can talk about. So what I decided to do is to kind of set the scope a little bit. So just scope for this presentation, not necessarily the scope of how I think about the world. So, and that's pretty much what you see on the screen. So cloud, this industry is full of buzzwords. We have clouds, we have events, we have SOA, we have ESB. We have so many acronyms, so many buzzwords. So, and cloud kind of like being one of the most prevalent one right now. So, and then there's event-driven architecture, event. Again, none of it is new, but there is like a renewed interest because of the cloud and microservices and new platforms that we currently have. And we're going to discuss the problem statement and kind of put it all together with the live demos using Spring. And if I may ask, I usually, there's time for questions at the end, and there will be time for questions at the end. However, I like when questions are asked in context. So if you have a question during the presentation, please raise your arm, and I'll be happy to answer that. All right? So, cloud. Now, what are the chances that if I ask everyone in this room to define what is a cloud, I'll get the same answer or even close to the same answer? Probably slim to none, right? And so I'm trying to define it for this scope as an ecosystem that integrates platforms and middleware in one cohesive hybrid environment, runtime. So, I mean, think about what you typically do as an application developer. I mean, the functional requirements, the kind of 80-20 rule, the functional requirements usually consist of only 20% of what you actually have to do. You have to integrate with messaging, you have to integrate with databases, you have to integrate with file systems, and all of a sudden, the actual requirement that you looked at and said, oh, that's easy, became not so easy, right? So the cloud outsources infrastructure concerns to the cloud provider via connectors and services. So how many of you use Cloud Foundry or play with Cloud Foundry? So you understand the idea of that concept. So cloud also provides a mechanism for application services, we call them clients, to interact with cloud services. So for example, you want to connect to Rabbit or Redis or something along those lines. Cloud provides you that infrastructure, and you can just simplifies connectivity to the infrastructure. And life within cloud is naturally event-driven. You have many applications that sort of, especially when we in the world of microservices that are self-contained, that are independent, but they all need to communicate with one another in some form or fashion. And they communicate by exchanging events, right? So, and that brings us to events. So events, again, it's nothing new. I actually am willing to go as far as saying events had existed since humans existed, because we literally live in the world of events. I mean, our entire day consists of processing events, right? So event, again, to try to define it for the scope of this presentation, is a representation of a state change, right? It's always in the past tense, right? You can't say, well, there is an event about the future. Even if you communicate me that something is going to happen tomorrow, and that's the event that you're delivering to me, it's already happened in terms of you telling it to me, right? So events are delivered usually in the form of a protocol-specific records using various different messaging systems. And again, messaging, I'm using it in a very vague form here because, you know, posting a REST request or posting REST or using publish-subscribe models like with JMS or AMQP or Kafka. These are all mechanisms to deliver and distribute events. And events are very simple structures. They contain what the actual event, and they contain certain metadata associated with the event. So I just want to make sure. OK. So now let's talk about the problems that, and this is kind of a very small subset, but let's try to discuss or talk about the problems that we face as developers. So we always kind of, like back in the JE days or J2E days, whatever you want to call them, we sort of lived in a single JVM deployment model. So we had these clustered servers, but once you deploy something, you deploy it to that server, to that instance of a JVM. So the way of modularizing and distributing was typically done through, you know, this heavy and convoluted class loading architectures. So that really didn't work. And it limits the management lifecycle characteristics of your service. And like I said, the shared resource problem that I just described is really a big problem, because think about what would happen if an application that you deployed coexists in an environment, an application server with other applications, and your applications, for whatever reason, run out of memory, or sucked all the memory, or sucked all the resources in terms of processing. You're essentially affecting everything else within your environment that you thought is independent. It really isn't. Infrastructure may leak into application code. So, you know, you implemented some functional requirement. Now you have to hook it up to a messaging system. So Spring has always been at the forefront of simplifying this process with templates like JDBC templates, Rabbit template, JMS templates, and a lot of other abstractions that would simplify that level of configuration. However, you would have to still do it yourself, right? But then when you write another application, you kind of doing it again. And then when you start realizing and looking at everything that you've done, the only thing that really changed is some of the configuration parameters. But that connection factory, the template, it was pretty much the same, right? And so that's kind of one of the part of the problem. So cross-platform integration, that's a big one, especially in the world of the cloud. And we'll do some demo today of that, where you know, not everything, I mean, as much as we like Java, not everything is Java, right? So you may be posting message from a system, some legacy system, to Rabbit, and using it as within the Java program, and posting it to another queue or topic, and using it with, I don't know, C++ program, right? So you need to be able to find a way how you can, I mean, the messaging system is kind of means to an end, but you need to be able to interpret and communicate some kind of a type information. So, and that's really gets us to event representations, like how do you represent event? How do you transform, convert, serialize? I mean, how do we do that? And who's responsible to do that? Is it going to fall into this 80-20 rule where you have to do that? Or we're going to reverse the 80-20 and say, listen, the framework will handle everything, and we truly going to only worry about the 20%. So content-based routing. We'll talk about this today as well during the demo. So that's really one of the core requirements every time you're dealing with any kind of event-driven system or architecture. And obviously different programming models. So how many of you guys are into like a streaming, like Java util stream style of streaming, like K-stream, like D-stream, right? Okay, there's a few hands. And that's a different programming model in itself because while it really is still event-driven model, it kind of allows you to maintain certain state, right? Where you can do, implement use cases with, tumbling window logic where you can, monitor things. So that's really the problem that when we started Spring Cloud Stream project, that's kind of the problems that we were trying to address, or some of the problems we were trying to address. So now I'm going to try to put it all together. And one of the projects that I want to start with is Spring integration. Now, how many of you are familiar with Spring integration as a project, not as just the general concept of integrating with Spring? Okay, so Spring integration is I'm not going to, I used to deliver many talks on Spring integration back in the days when I was working on it, but right now I only have basically a single slide. It's a messaging framework which provides implementation of AAP patterns on top of Spring messaging. And it's interesting. So first of all, are you guys familiar with this book? Okay. So first of all, what's interesting about this, what I wrote there is on top of Spring messaging. 5 years ago, that would not be true because Spring messaging was Spring integration. The message abstraction, the message handler abstraction, the channels, everything was within Spring integration. However, we realized that there is extremely big value outside of Spring integration to use these abstractions. And we pulled it out from Spring integration, and right now it's part of the Spring core. So now Spring integration depends on it, and now there's other parts of Spring that utilize Spring messaging. So basically, there's two frameworks out there. And we are into our first demo. All right, first of all, how do you guys see the code in the back? Is it all right? Because I'm almost running out of real estate here. All right, good. So I really need a bit more real estate here. But anyway, so again, I don't want to concentrate on some heavy functional requirement. I just want to say, okay, well, here's an event that was delivered, and I have this method called handle. And right now, we're going to change it many times today, but right now my event is just a string, right? And I'm just going to print it out. And that's my processing. You obviously understand that within that code, instead of system.out or print line, will be your functional, your business logic to process or consume that event. So first of all, right off the bat, I mean, as you can see, there's no configuration, no notation, nothing, right? This is just a plain old Java object and a plain old Java method, right? So what's interesting is that that method represents how you think about functional requirements, right? Because when it says, well, the message is going to be delivered from Rabbit or the message is going to be delivered from some other system, that's not a functional requirement. That's the non-functional requirement, right? But the functional requirement is, okay, well, you're going to get this piece of data, this event, and you're going to have to do something with it, right? So what it immediately allows you to do is testing. A simple way of testing your functional components, right? And I'm sure you guys are big on testing, right? Good. So, so now, because of the Spring Boot and everything, my application, I'm basically bootstrapping this application. And right now, it's within my application, there's a method. So I can basically auto-wire my application because it's that's my application context. And I can auto-wire it, and I can simply invoke that handle method with so it's going good. So, and we got it, right? So now, obviously this is beyond hello world. This is too simple, right? So, but now we want to be able to, like for those who are already familiar with Spring integration, we want to be able to actually send the message not directly to the handler, but to send the message to the channel to basically emulate the real-time scenario, right? So what do we do here? We can, how many of you knows being with Spring long enough to remember XML way of doing things? All right, good. I still like it. But I'll tell you why I like it. I mean, when it comes to this type of, not for everything, but for this type of, for example, for Spring integration for my own demos and prototypes, not for this one, but at home, I still use XML because it gives me this one single place to envision what's going on, and we still have that IDE support where you can switch to a different tab, and all of a sudden you have this graphical representation of it. So, but anyway, so right now all I'm going to do is, so first of all, look at my POM. I have Spring integration added to the class path. So now I can simply annotate with add service activator. Say input channel equals input, and we're done, right? So now I can go back to my test. I can uncomment this piece of code. And now I can deal with this test where I can actually do the same thing, but right now I'm actually sending the message to the channel, and the system, the Spring integration, distributes, I'm sending event, if you wish, to the channel, and the system, like the framework, in this case Spring integration, distributes this event to the handler that was attached to it, right? And right now, if I add another handler to this method, you would be able to see the load balancing, and you can configure that as well. So all of a sudden, you can see how the framework, by just simply plugging in the framework and providing configuration. Note, I didn't change any of the code. My code, let's pretend that this code truly represents my functional requirements. I haven't changed it, but I'm able to plug in my code, my functional requirement into, or integrated with an event delivery mechanism provided, in this case, by Spring integration. And you can also see the two types of testing that you can do. So one is what I would call a true unit testing, where you simply testing your actual handler. And another way is the integration testing, where you're doing the same thing, but now you're actually asking Spring integration to distribute message for you to that handler, and so on. So, but now, because of Spring integration, we'll cover it in a few minutes, but you'll get all the management, monitoring, and all the extra features that fall into this whole 80% category that otherwise you would have to implement. I'll demonstrate some of those features when we get to the Spring Cloud Stream part, because I don't want to waste too much time on Spring integration right now. So, so how do we, so at this point of time, we have, we've demonstrated how we can integrate with event delivery mechanism, but I'm going to switch to slides, and let's talk a little bit about pros and cons of this approach. So on one hand, I was able to maintain my Poja model to implement my functional requirements, right? I was able to seamlessly integrate it with an event delivery system provided by Spring integration. However, imagine you have another event handler, you have another event handler, you have many event handlers, and we go back to this problem of shared resources, both file system resources, memory, CPU, and so on and so forth. And all of a sudden, you know, if something crashes, you're affecting the rest of your application context because it's running as part of a single application context, part of a single JVM, right? So, and again, I don't want to go too much about pros and cons, but that's really the main one, is like the shared resources, and that's really where I believe the core problem kind of resides. So now we're getting into Spring Cloud Stream, and how Spring Cloud Stream essentially takes us to the whole new level of doing the same thing, what I just did, but now in a distributed cloud environment. So I'm going to switch back to this slide, for example, just for a second. So pipes and filters, that's the core of Spring integration. That's the core of it. That's a very fundamental, that's a fundamental block for enterprise integration patterns. So you can see the pipes, they're the channels, and the filters could basically your handlers, routers, whatever they are, right? So within Spring integration, they're just components of a single process, right? But now, what's interesting is that if I were to draw the same diagram from like what represented here and said that's a Spring Cloud Stream, how much of it do you think would change? None. Because the filter, the box, doesn't really necessarily represent that whether it's running in a single process or in a distributed process. It basically explains that this is what's going to happen here, and then once it happens, it's going to be delegated to the next pipe. And once it's delegated to the next pipe, it's going to go to another handler, and so on and so forth, right? But those handlers themselves could be either components of a single application context, a single process, or could be distributed microservices. So let's start looking at Spring Cloud Stream. So how many of you are familiar with Spring Cloud Stream? All right, good. So I was hoping not to see a lot of hands because I'm like, what am I doing here? But thankfully, I'd say about 20%. Good. Hopefully, you guys will learn something new. But otherwise, I'll reiterate what you already know. So Spring Cloud Stream, it's a framework for building message-driven microservices. And message-driven, event-driven, I kind of forgot to say it at the very beginning. For me, it basically, message and event is a synonymous. Just event is more of a concept, where message is kind of like interface and implementation. Message is just it's a mechanism to represent the event, right? Because message is the simplest imaginable structure that you can possibly think of, right? It consists of two parts, payload and headers. And headers is a map, which means you can throw anything in there, right? So in other words, it's very easy to use message as a concept to represent an event, but also interrupt with other systems, because whether you're writing a C program and I'm in Java and you're in Python and you're in Go, we can say, okay, I'm going to send you the message, and that message could easily be represented in something like a JSON or something, and we can all live together and coexist. So it provides boot-driven integration with message brokers using binders, and we'll talk about it in a few minutes. So the binders are, well, they're binders. They're binding your code just like I just bound my code to a channel through annotation. So the binders will take you to the next level and will bind you to an actual messaging system, whether it's a Rabbit, Kafka, or whether it's something custom that you've implemented on your own. So it leverages features of the brokers while also providing workaround for not supported features. So for example, partitioning. How many of you are familiar with Kafka? Good. So Kafka provides both partitioning, consumer groups. That's the native feature, and we simply delegate to that native feature when you writing a Spring Cloud Stream app and you're interested in using those features. But what about Rabbit? Rabbit doesn't have some of these features, right? So, but because of the Rabbit architecture, because it could be done through, and if you are more interested in how it's done, talk to Mr. Russell over there. There are ways to represent message groups and partitions within Rabbit. So it required a lot of code on our side, but think about the benefits that you're getting, because now you're thinking, okay, well, I'm going to implement a messaging or event-driven system, and I need to benefit from the concept of partitioning and consumer groups. But I'm stuck with using Rabbit instead of Kafka. Well, guess what? You can do that, right? Even though if you had to do it yourself, then you would have to essentially do what we did inside of the Rabbit binder. Message headers, where I wanted to mention that even though with our current distribution, it's no longer sort of relevant. I guess maybe with Kafka 10 it's still a little bit relevant, or no? Yeah, because Kafka 11 started to provide native support for message headers, but until then it didn't. But what if you want, I mean, message like metadata, like I was talking about earlier, metadata with an event. What if you want to pass some meta information with your message, with your event? How would you do that? Either you have to do it yourself, or you have to rely on a framework. But the framework, let's say, uses the middleware that doesn't support it. Well, we implemented a few tricks to actually support it. We were embedding it in the actual payload, and then unembedding it essentially on the reception side, on the consumer side. So, but it was all transparent to you, and you just use it as part of the framework, right? Without even knowing what's going on behind the scenes. So it also honors application configurations by underlying framework. So that's actually very interesting because I was a little surprised where I saw some annotations like we have. And I'll get to it in a second, but we have Kafka listener, we have stream listener, we have service activator, and I'm like, well, why do we have, well, service activator I knew that came from Spring integration. Kafka listener, I kind of assumed that it kind of coming from Spring Kafka, and then we have stream listener as part of the Spring Cloud Stream. The irony of it is they're all interchangeable. But and on one hand, you may say, well, listen, why do you need 3 when you can pretty much handle everything with 1? But the interesting thing is that the reason why I started with Spring integration is because it's a very nice path to model your microservice event-driven system before you actually get into a distributed environment like Spring Cloud Stream. But 2 months ago, before I joined the actual leadership role for this project, we have this new role called the Spring Advisory Architect, and I was with a client, we were trying to implement a particular use case, but nobody could clearly state what the use case is. So we were kind of going back and forth and so on and so forth. So I decided, you know what, let me just start modeling it using Spring integration. And by the way, that's when I used XML again. So we start modeling, and it was a pretty complex use case, but it was easily modeled using Spring integration. But the interesting part about that was that using Spring integration, not only we were able to kind of settle on what the use case is, the reason why we were able to settle on what the use case actually is because they were able to envision where it starts and the end result. So they were able to validate that the requirement is correct. It's just that in a non-functional world, it is not correct because it has to be in a distributed environment. But we were able to emulate all of those aspects within using just Spring integration. So in fact, back in the days when I was engineer on Spring integration and delivered presentations on it, I always said, and you can find those videos in the FAQ, the Spring integration, if anything, it's a great modeling tool. You can model pretty much any life scenario with it and then say, okay, well, now I have a working model. All I need to do is just take all those handlers and implement them or factor that code out into microservice. So, which brings me back to what I was just saying, that it honors other applications configuration, because you may have modeled it using Spring integration and you're familiar with service activators, transformers, routers, filters, and so on and so forth. So why do you have to change it back to stream listener? You don't, if you don't want to, right? So you can just keep service activator. If you're using Kafka, Spring Kafka, and you implemented Kafka listener, and now you want to migrate this whole code into running as a microservice within Spring Cloud Stream, you can change it to stream listener, or you don't have to. We will honor that. Okay? So, question? No. All right. So Kafka and Rabbit are currently supported binders that we have, but there are a few JMS binders coming in a pipeline, and then there is a lot of talk about Event Hub, GCP, Google, all kinds of different binders that we're partnering with the companies as well as the community delivers or proposes to us through pull requests and so on. So here's kind of a graphical view into what Spring Cloud Stream is. So I decided to play a little bit with this animation. So we have this pops up destinations. That's how binders how binders integrates with your actual applications. We have content negotiation provided by the framework, and we'll cover this in a minute. And Binder also either integrates with the consumer groups and partitioning or provides a workaround that it would appear to you that a particular messaging system or the delivery mechanism supports it, even though you may natively not support that. So kind of a quick summary. Durable publish subscribe messaging for easily creating complex topologies. Consumer groups, multiple instances can be competing consumers when scaling. So partitioning, you guys, how many of you familiar with the partitioning consumer groups and why it's relevant? Would you like me to talk about this?
Yes.
All right. So because partitioning, let's say you have a problem where you have an event stream, message stream, and each event identified with some natural key. And the ordering of event processing is important as long as the natural key is the same. But if it's different, like different event type, for example, you can process them in parallel. What do you do? So it's a common problem, and but partitioning is what allows you to do that. Basically, it says, listen, I want to preserve the ordering characteristics, right? But at the same time, I also want to introduce a certain level of parallelization, all right? And although it's a kind of a not very clean cut, because at some point of time, you just have to pick a number. So I want to have 4 partitions, 10 partitions, whatever partitions. But it is, and there are other ways to customize it. I mean, but you have to write some code. But at least for majority of the use cases, that's a pretty decent solution, right? Consumer groups is basically to kind of deal with the problem of competing consumers, right? And Gary, could you speak a little bit to consumer groups? Yeah, can you bring up that mic?
Yeah,
so you have a better.
Whoa.
Yeah.
Testing. So consumer groups, normally a Spring Cloud Stream app, if you don't give it a group, every instance gets every message, right? So in the case of Rabbit, we bind an anonymous queue, auto-delete queue to the exchange. With Kafka, you get a different group ID. So the notion of a consumer group is to enable you to, it's a pub-sub paradigm where the producer is sending messages to the topic. You can have multiple consumer groups, but within a particular group, they compete for messages. So instead of everybody getting every message, it's a way of distributing the work. And the way that works with Kafka is partitions are assigned to individual instances of the app. In Rabbit, we do it by, well, Rabbit does it intrinsically just because a queue does have competing consumers on it. So.
All right, thanks, Gary. I figured if your name is on the door, I'll give you 5 minutes. So content negotiation, obviously, it's the, we need to know what we're receiving, how to interpret it, how to deserialize it, serialize it, and so on. We have Avro support within Spring Cloud Stream and many other interesting things. So programming model, not very different from what you've seen or used to in Spring integration. Spring Cloud Stream is nothing more than a Spring Boot app. Just pretty much everything right now in Spring. And you can use the starter projects, the spring.start.io to create, in the starter apps and then continue from that point on. By the way, did you guys ever seen Josh Long presenting or seeing his rant on the spring.start.io? If you feel depressed, neglected, suicidal, go to spring.start.io. So yeah, it's a pretty cool resource because it allows you to quickly, like if you think about back in the days when you have to start a new project, that extra 5 minutes was just annoying, where you have to create a new project, create a POM file, and do this, and that, as opposed to, and then kind of think about all this stuff, as opposed to say, listen, I want this project with these flavors, and everything is just packaged and created for you. So flexible configuration. We still support XML, and like I said, some of us still like to use it occasionally. But annotation, and then obviously a hybrid approach, where you can use both. Binders, so we have, so the binders, again, we could speak on that topic for hours, because there's a lot of interesting things within the binders themselves. Like, for example, we have a channel binders and we have streaming binders, or PubSub binders. So this is what declarative binders, where, and I'll get to the point. So KStream is one of the binders that we support right now as for part of the kind of a streaming binder. And then we have channel binders that also support Kafka and Rabbit. That's what I'm showing here is what we actually support. So there are other binders. There is, like I said, JMS binders coming in the pipeline. The problem with JMS binders, because JMS is really, was supposed to be a specification that defines a standard, but it's really, ActiveMQ is not working the same way like IBM MQ versus Solus versus, different systems behave differently and expose different features. So it's not easy for us to provide a generic JMS support. So, but it's coming. And seamless integration with the rest of the Spring Cloud stack. So metrics, sleuth, config, circuit breaker. I mean, you're familiar with the whole bucket of Spring Cloud projects, connectors, and so on. So, I mean, it's all by simply importing something into the class path, into a POM file or a Gradle build, you're getting those features, getting those features. So this is really what I was trying to show you earlier, is that kind of a quick view into imperative versus declarative programming model, where basically what I was trying to demonstrate here is that the two pieces of code will essentially do the same thing, except that one is a true message handler, which is basically event handler, which will act on each event, and that piece of code will execute, where the declarative simply provides a structure that will be bound to the actual stream, to the target stream. In this case, it's Flux, but it could be KStream or DStream or whatever. And now you can implement a more complex logic to do more complex data analysis, where the state or of some type is necessary. So I think we are getting into the demo part. So let's go back to where we were. So now, I don't want to change anything here, but what I want to do, I want to introduce Spring Cloud Stream into the picture and use RabbitMQ to interact with it, right? So my code still is the same. So I'm going to go to my POM, and I cheated. I already had it there, just commented out. Now, because Spring Cloud Stream already depends on Spring integration as a dependency, so we can actually remove this because it's transitively pulled in by Spring Cloud Stream. And in this case, we're not just depending on Spring Cloud Stream, we're depending on Spring Cloud Stream binder Rabbit, which pulls Spring Cloud Stream, which pulls Spring integration. So we essentially said, okay, well, we want to use Rabbit, right? So now think about what I actually, how many of you been to Phil Webb's keynote yesterday? He said something interesting that I don't necessarily agree. He said Spring is no longer about dependency injection. I actually think Spring is even more about dependency injection if you just look at it a little slightly differently. Dependency injection historically been, okay, well, we create this application context and a very nice mechanism to inject objects and collaborators into your application context or within the beans themselves. However, now we're doing the same thing, except we're saying, listen, dependency is now defined by class path dependency, because the jar is no longer just a jar file. It contains configuration that will be read through Spring factories, that there's a convention there. And all of a sudden, you're going to get a lot of stuff that you otherwise would have to worry about yourself. Let me give you an example. So let's say you're trying to write an application that integrates with Rabbit. So you're going to import Spring Rabbit into a class path, and then what? Then you have to, first of all, if you're importing Spring Rabbit into a class path, then you obviously have intent to use it, right? But the using would mean you have to create a connection factory, Rabbit template, and everything else. Well, but the reality, as I said before, the only thing that's different is configuration. But just like many middleware provide default configuration, default user ID, password, port, and URL, and so on and so forth, we could just simply say, OK, well, if you're importing Rabbit into a class path, you must want to use it. So we're going to say, OK, well, we're going to assume that you're running Rabbit on a local machine, and we're going to try to connect to it. And if not, you can provide configuration to which Rabbit you want to connect to. So in a way, by simply importing Spring Cloud Stream Binder Rabbit, I've not only declared my intention to use something like Rabbit, I've also declared connect and give me connection factory. So for example, right, I could, in my test, if I really wanted to get access to connection factory, I could simply auto-wire it in my test, and it would be given to me. Now, AV guys, I'm having a bit of a problem because I'm almost running out of battery, and I'm plugged in. So let me see if this would work. All right, yep. OK, I'm glad I noticed it. So, all right, so now I have a Spring Cloud Stream application. Well, I have the same application that I had before, but right now it's a Spring Cloud Stream application. Well, not quite yet. So what you need to do is say enable binding, and say I want to make it, a sink. So we have processor, sink, and source. And those are nothing more than basically declarations for the channel. So if you, for example, look at one of those annotations, you'll see that it's nothing more than declaration for a channel that you want to interact with and giving it a name. So you can create your own bindings as much as you want. So we just provide you with the 3 core concepts. So in this case, the reason it's a sink because it's a typical handler. I'm going to receive and process, and that's it, right? So if it's a processor, then I'll be able to receive, process, and delegate it further down the pipeline. And if it's a source, then it means I'll produce something, and I'll delegate it to the pipeline. So that's pretty much where we are. So other than that, nothing else changes, right? But here's the interesting thing. So now I'm going to run this application. I'll just run it as a boot app, not even as a test. So and I can go to Rabbit instance. You can see here I created anonymous queue for the input. I can publish message, hello world, publish message, and we should see it right there. So all of a sudden, again, that same code, that same configuration, but all of a sudden I'm now talking to it through some type of messaging middleware. And if I wanted to truly send the message, programmatically to Rabbit, I could create another application that essentially acts as a producer, or I can just inject Rabbit template and use that to send message to the exchange, and it will be delegated to the appropriate queue. So there's many things that I can do to either facilitate the testing or to kind of demonstrate, and so various different aspects of it. So now let's expand our. Oh, I thought somebody said something. So let's expand our use case and talk about your typical use case when it comes to event-driven architectures. And that is the content-based routing, where you can, this handler is specific to this type of messages or events, and this handler is specific to this type of events. Well, obviously, for those of you who are familiar with Spring integration, you know that it's very simple by simply introducing a router into your configuration, and then provide the routing configurations, how do you want to route the messages. And we have quite an extensive library of routers. And there's always Spring expression language, which even gives you more flexibility with how you want to route things. But when you think about content-based routing for the event-driven systems, you realize that this is one of the core requirements. It's kind of a specialized use case. So it's like you constantly have to, when you're creating a handler, you almost have to constantly think about how I'm going to route the message to this handler. And because of that, we created this annotation within Spring Cloud Stream. So that's a native to Spring Cloud Stream annotation called Stream Listener. So now I'm going to slightly change configuration. Again, the code stays the same. So now I can actually write a condition to say, listen, I only want these type of messages to go to this handler. It's kind of like a filter, right? So, and I can route either on the payload itself, or because it's going to be receiving a message, I can route based on the headers, right? But here's an interesting thing. Where is the actual message? Because my input parameter is string. Well, the message is, the interesting thing about, and this is kind of, again, part of Spring integration, I could change it to message, and I will receive the actual message. But I can change it to string, and I can receive just a payload, because the smarts of the underlying frameworks looks at the type that you're requesting, and there is, again, certain convention to say, listen, if you're just including a simple type, then we're going to assume that that's a payload. So we're going to extract the payload from the message and give it to you as that, and attempt to give it to you as that type. And if there is any conversion that has to happen, and I'll show it to you in a second, then we'll do that as well for you. Okay? So, but what's important is that the above thing is configuration, which means that it still has access to the message, and we can either do payload that equals something, or in this case, I'm going to do headers, what is it? Something like that, right, Gary? Yeah, so basically what I said, if there's a header, only deliver messages to this handler if a header with that contains event type value foo is present, right? So now I can start this application again, and it's a stream listener. Okay. All right, so now I can say event type. And we got hello. But if I do event type bar, we got the warning that we can't really deliver it. And now we can try to come up with different rerouting logic. We can configure it in so many different ways, or configure the dead letter queue to say, send those messages there. But we can also introduce, say, listen, I don't want to, I think I was reading Dave Taransky's blog, which I'll actually link you to. He was saying that, like one of the jokes that, we could always introduce the switch case statement inside of the method, but that really wouldn't be all that eventy. So yeah, we can introduce the switch case statement and eliminate all these conditions, but we really don't want to do that. So instead, I can just do another favorite thing, is just cut and paste, right? Right, so I'm going to do handle bar, and now I'm going to change bar, and just to get a little difference. So all of a sudden, I'm binding to the same channel. Oh, what happened? And we got now delegated to bar. So now we have this, in other words, instead of you writing a switch case statement, obviously it's a switch case statement or if and else statement, but it's not done by you. It's like 1 line or 2 lines or 3 or 10 or 1,000 lines of code less for you to maintain. So, okay. Another interesting things when it comes to the actual event-driven systems. I mean, so far I'm only covering functional requirements and some of the aspects of non-functional requirements. But let's talk about the status of the system, the being alive, right? You know, how much information do you get about your system? That again falls into this category of 80% because, you know, functional requirements are usually simple to implement. It's what's everything else that's required by the system to provide you a variety of different notifications, management, monitoring, you know, and things of that nature. So, yes, I'm sorry. Go ahead. Could you repeat, please?
Are there any functional equivalents to the string listener annotations, similar to the router functions in Spring Web 5?
So are there any functional stream listener equivalents of the Spring Web 5?
You showed it on your slide. You have that flux.
Oh, yeah. Sorry.
Not the reactive web, just the router functions, so that you don't have to know what the condition syntax is and can instead find it in actual code logic.
No. I'm saying no because I'll basically say I'm not really fully, maybe we can talk after because I'm not fully understand the actual problem. And that's not on you, that's on me. Like I need to better understand because it's either we don't have it, not supporting it, and there's a reason for that, or we don't support it yet because we haven't gotten there yet. So that's kind of the answer that I want to give. So, all right. So let's quickly look at some other things. So I did a little cheat sheet right here. So I'm going to stop this application and kind of show you a little bit of other cool stuff that is provided. So we're going to provide a few properties. Oh, okay. Right. What else is there we're going to do? This is enough, right? So I'm going to start the app again, but now, well, let me get into full info logging so I can show you something. So you're familiar with the actuator and actuator endpoints within Spring Boot? Some of you are. So I mean, not only did we give you frameworks that allow you to kind of bind to a variety of different event-driven systems and implement a variety of different event-driven architectures, but we also give you a system that also exposes you to a lot of out-of-the-box ways to monitor, manage, maintain, and essentially see what's going on with your application. So if you look at the console, I don't know how many of you actually paid attention to these log messages. So these are all endpoints that are bound to this particular service, right? So now, if I go to localhost metrics, what you see on the screen is just all the type of metrics that we are exposing, right? But if I go to I have stale instance of Visual VM, so sorry. All right, so here's my SpringOne demo application. And here's the mbeans, and we got integration, message channels. So we got all this good stuff. And then, where's the metrics? Huh. All right, well, a little mishap. But anyway, there's a lot of Spring integration already provides it, so that, but there's also a metrics module like micrometer stuff that I was expecting to see there. But oh, I know why I didn't see it there, because I didn't expose I have to bring again another starter into my class path, micrometer JMX, which I'm not going to do right now just to save time. But anyway, that's the stuff that it gives you. But let's actually also go to, you know, oh, if I learn how to spell, right? So all of a sudden, like, I can get a thread dump at any point of time of my actually running application. I can get the health of, and you can pretty much click on any of those endpoint, and it's up. You can get a lot of information. And again, these are all the requirements that otherwise you would have had to implement yourself. We're giving it to you sort of out of the box. So I think happens rather rarely, but I think I am. This is trying to see what else I can show you that would be simple enough. So we did routing. Yeah, okay, Gary, see if you can.
I think I'm going to suggest is just if you're in the department, just switch it to Kafka. I mean, not you have to run it.
Oh, yeah, yeah. So the interesting thing is what Gary pointed out is we introduce Spring Cloud Stream by means of bringing Spring Cloud Stream Rabbit binder, right? But I just switched to Kafka. You can see none of my code broke. And if I just don't have Kafka running right now. I actually don't even have it installed. I was trying to stay away from it for a little bit. But I mean, if I had Kafka running right now, I could just run the same app again, but using Kafka. And that's the only change that I had to do to switch to Kafka for this specific use case. If it was something more complex, then I would have to provide, if I have to, let's say, provide non-default configuration, then yes, you would still have to, because the configuration is specific to a particular broker, right? Your URL properties, your port properties are different for Kafka than for Rabbit. So those, but that's again, that's a configuration. I don't necessarily claim it to be part of a reusable code. That's specific to.
The same job could be used in both environments.
Yeah, and yeah, I think you're talking about the ability to say my consumer is Kafka, my producer is Rabbit.
Well,
That okay, that too.
it's just configuration.
Right.
Application properties.
Okay. Oh, one more thing I want to show you. So I was talking to Spencer yesterday because I was trying to get a feedback on as I was preparing the presentation, and one of the attributes of a true microservice is its resilience, right? So let me go back to Rabbit. Wow. Okay. And what I'm going to do right now, I'm going to kill the bunny. All right, it's gone. So I'm going to start my app. All right, so let's look at the messages we're getting. You see there are just constant retries, so it attempts to reconnect. And, the application is alive, doing fine. It's just that right now, it has a hard time establishing communications, but it's trying. And as soon as I resurrect the bunny, you can see that it's connected and did all it had to do in terms of declaring queues, exchanges, and everything like that. Now, I'm going to kill the bunny again. An unexpected error. So again, think about the amount of logic that you would have to implement and think to actually accomplish that. And then you have to do it again over within other applications where Spring kind of stays one step ahead of you because we communicate with a lot of different customers and sort of familiar with a variety of different use cases and always try to get the feedback from you, the community, and say, listen, this is really a common problem. Let's solve it at the framework level so you don't have to, right? And at the end of the day, I don't want to sound like a sales guy, but in a way I am, because This is less code for you to maintain. You can point a finger at us and delegate it to us, and we'll gladly fix it for you because now it's our responsibility. And at this point, I am done. I think it's the... I'm sorry? What I have shown, the only Spring Boot 2 is the actuator, like, I mean, there's a whole blog. The Spring Boot 2, the actuator endpoints have changed, but the stuff that I showed you, just the URL would be different when it comes to like metric stuff and info and statuses and all. So all those endpoints are right now remapped differently within Spring Boot. So if you go to the previous version of Boot, the functionality is available, it's just under different URLs. But no, it doesn't require Spring Boot 2 to do everything I showed you today, because that's really... Yeah. But I mean, oh, yeah. Well, actually, let me take that back, because the way, like what I'm saying is that there's no features specific to Spring Boot 2, right? But the way we delivered the project, let's say I haven't tested it on Spring Boot 1. Whatever, and I don't know whether it will work. But Spring Boot 2 is going to be out within a couple of months, so I guess the answer is yes. Sorry.
So when's support for JMS and IBM MQ coming?
It's a good question.
Someone had a project going. I think it was someone within Pivotal had done it, but it wasn't official. They had required topics, and we don't have topics. We just had Q and Q.
Right, and that's part of the problem which you're describing is that so the question, I'm sorry, the question is when will we provide support for IBM MQ, which is JMS, right? That's what you were saying?
Right. Well,
yeah. Yeah, so there is a snapshot implementation of Spring.
I think I can.
Yeah.
There is some work going on in that area. We're actually talking to IBM as well. We don't have a milestone yet, but we do have an MQ broker, MQ binder, and as well as an active MQ. The problem is that in order to get consumer groups on topics, which is a requirement for this architecture, it's an extension to JMS, and both ActiveMQ and MQ, WebSphere MQ provide that, but it's still in the sort of a beta.
My problem is that it was requiring a topic, and I didn't have access to a topic. I only had access to queues like that. So it opened connection to a queue and a topic, and it wasn't a topic, it was a queue.
I haven't been involved directly with that, but ActiveMQ, for example, has got this notion of a pseudo topic or some where
it's a virtual topic.
A virtual topic,
yeah.
So you can effectively have competing consumer groups on topics, which is not part of the JMS standard. And my understanding is MQ has a similar feature, but it's just configured differently. And there is, as I say, there's out in the repo, there's not been milestoned yet, but we're actually, I've heard that IBM are actually interested in creating a binder for MQ. So
that's what I was saying.
We're actually in the process of talking to them, maybe even at this show.
Yeah. I want to give that guy right now. Yes, and then you. Yes.
Now, my idea is what you have a jar, and then on the fly, maybe depending on configuration, you can switch between Rabbit and or Kafka.
Okay.
Yes, you can do that.
Okay?
Yeah.
How can you do that?
It's all in the application YAML or application properties. You just set up each. I guess you didn't show an application YAML file, but. By default, you set the binder properties, and if you just say Spring Cloud Stream binding foo.destination, then it uses the default binder, or you can actually explicitly have a binder property on the thing, and then you can set the environment for each. So you can have a Rabbit binder and a Kafka binder, so you can receive a message from Rabbit and send it to Kafka, or you can have two different Kafka binders, talking to two different Kafka clusters. And then it's just a configuration to say this particular channel needs to be bound to this binder instance.
So what you see on the screen is actually Spring.Binders configuration for Rabbit binder, and the Rabbit at the top, that's the name of the binder. So what Gary was pointing to is that you can, if you have two binders on the class path, because you may be receiving a message from Rabbit but sending it to Kafka if you're a processor, right? Then you'll be able to actually have two binders at the same time and say, I want to use this binder for consumer and this binder for producer.
If you go to the Spring Cloud Stream reference documentation, it's all explained in there how to use multiple binders with the framework.
The thing you just showed where if the RabbitMQ server is not running, you want to bring up your application.
Yeah.
Is there a different configuration that to do? I think my project right now, it has a dependency on Rabbit when it starts up, and if that Rabbit is not running, my application just keeps connecting, but it's not up.
What?
Do you need to do any separate configuration on which you said?
No, that's the default behavior.
Yeah.
A lot of people, though, make a mistake of trying to interact with messaging systems too early in the application context lifecycle. So, for example, if you don't start sending messages in a post-construct method, right? Because the application context isn't baked yet. You can't really start sending messages until the context is up. If you try to do that, you will get a failure. Correct.
Yeah.
Correct.
Yeah,
Yes.
we can do it right now.
Absolutely. Yeah, well, it's already down, right? Yeah.
Well, I can start up. Yeah, but basically, I would just.
Yeah. The only thing, as I said, you must not start interacting with Rabbit until the application context is
initialized.
Completely initialized. Either via application context refresh event or put your bean in a smart lifecycle and put the code in start or something like that. But we see that all the time on Stack Overflow. Oh, my application context won't come up. Well, it's too early to do stuff in post-construct methods.
Right.
Just having simple Spring AMQP in it will also have the same behavior, right?
Yes. Yeah. AMQP does.
Yeah.
The one thing that that this framework does on top of Spring AMQP is it's all opinionated. It'll go up and it'll create the exchange for you. It'll create the queue. You don't have to define all the queues, exchanges, and bindings. The binder does that all.
But you can if you want to.
Yeah.
So I mean, maybe for the next iteration of this presentation, I'll include the hierarchy. So what's included, because it may be confusing that by importing Spring Cloud Binder Rabbit, it contains certain configuration, but it also pulls in Spring AMQP and Spring Rabbit, which also contains configuration. It also pulls in Spring Integration, which also contains configuration. And now everything comes together as part of the boot-style dependency injection, I'm going to call it.
It builds on boot's magic, right?
Yeah.
I mean, boot is opinionated. It gives you an opinionated set of configuration. Spring Cloud Stream does the same thing, but a layer above, because it actually goes out and declares exchanges, declares queues, declares bindings, and so it means less work for you guys to do. It just
So basically, if you disagree with our opinion, go use struts or something.
Right, but much as with boot, if you don't like the opinions, you have complete freedom to.
You can always
do your own thing.
back away and pretty much override anything. Provide your own Spring.Factories and yes.
I heard you mentioning that XML is still a very good way of representing a Spring integration flow, right?
Yeah.
I think I like that statement. Probably is that the best practice that you still continue your Spring integration in XML and then
Gary is the project lead for Spring integration.
Yeah,
so
there's no. We don't have any intention of deprecating or removing the XML config. One thing we have done, which you might have missed over the years, like 4.3, it might have been 4.2. One of the limitations of that graphical thing in STS is it only can look at one file. It doesn't handle imports. It doesn't handle annotated classes, so you don't see those as part of the integration flow. We now have, you can now enable, and it's all in the documentation, you can enable an endpoint in boot or in any web app that exposes the entire application flow, the context flow, as a JSON object model, where you've got, source, channel, processor, all of the pipes and filters represented in JSON. And in fact, the Spring Flow project, which is the base of the UI, now has a sample called Spring Integration Flow. If you go to the Spring Flow thing, which actually does a JavaScript, actually you connect to the running application. You just put the URL of that integration endpoint in the application, and it pops up the
You should do a blog on that.
Runtime flow.
You showed it to me. It's an interesting thing.
But that's So I think I showed it at last year's SpringOne. So if you find my talk from last year.
Yeah. Any more questions? Yes.
You talked about the support for the message header. So if you wanted to do any kind of authentication, what is the best approach?
If you want to do what?
Authentication before you process a message, you want to make sure the header contains some kind of a token, some kind of an authentication that I want to do.
Well, I mean, that would get into the whole Spring security discussion.
I mean, you can. I mean, on the sending side, you could encrypt the authority or whatever it is from Spring Security and add it as a header and then validate it. Or on the receiving side, you can have sort of like a trusted token. Like if this message doesn't have this trusted value, then I'm not going to process it. But yeah, you can. Spring Security's got some new features about how to propagate security context, and you can take advantage of that.
All right, thank you very much, guys.